Invisible in radar and deadly in effect, China's stealth fighter has taken the next giant leap, equipped not just to avoid detection, but to seek out and neutralize the sensors that track it. This isn't just a weapons upgrade. It reshapes how air missions work. We'll dive into how this capability was built, why it's a turning point, and what it might mean for the future of aerial power. Stay tuned, because what follows changes the game. China has combined high-stealth aircraft with specialized radar-seeking missiles, creating a capability few have achieved. The thrust of this development centers on the missile designated LD-8A, designed to home in on radar emissions and strike the source. This weapon was publicly displayed alongside the stealth fighter J-35A during China's Changchun Air Show, signaling integration of missile and aircraft. The LD-8A shares aerodynamic similarities with China's PL-15E long-range air-to-air missile, which suggests China reduced size and optimized stealth-friendly carriage. Meanwhile, the J-35, built with internal weapons bays and low observability features, is suited for this missile because it can carry it without compromising its stealth profile. Chinese observers note the pairing indicates the J-35 may undertake missions historically reserved for electronic attack or dedicated radar suppression platforms. Crucially, the LD-8A's ability to track radar emissions means the J-35 can approach contested zones, detect emitting radar sites, and engage them while maintaining stealth. This tight coupling of aircraft design, weapons carriage, and mission effect is what sets this capability apart. Where earlier stealth aircraft focused primarily on avoiding detection and engaging other aircraft or high-value targets, this new combination emphasizes suppressing the foundation of air defense, the radars. That transformation, from flying undetected to proactively disabling detection systems, is what places China at the frontier. By blending missile, platform, and mission into one integrated system, they have opened a new chapter in how stealth can be used. The importance hinges not just on each component individually, but on how they function together. Stealth aircraft that can carry anti-radar missiles internally and strike with little warning. In short, this is not about incremental improvements. It's about a shift in role and capability. To fully appreciate this capability, it's essential to examine why major air forces haven't yet fielded the same level of stealth plus radar suppression integration. In the United States, for example, the F-22 was built for air-to-air dominance. While stealth was central, air-to-ground and radar suppression roles were not originally emphasized. Internal bays were configured for air-to-air missiles and budgets shifted. The F-35, designed to be multi-role, was set to integrate advanced anti-radar weapons like the AGM-88G AIR-GMER, but programs have experienced delays and operational deployments remain limited in this area. Russia's stealth effort with the Su-57 likewise shows advanced design, yet there is no open evidence of a fully integrated stealth fighter with internal anti-radar missiles in regular service. Several factors explain these gaps: platform design choices, mission priority trade-offs, budget and timing pressures, and reliance on legacy radar suppression systems. The integration of internal carriage, stealth-friendly missile design, sensor fusion, and operational doctrine must all align, and that alignment has proven difficult. China, by contrast, appears to have synchronized these elements, developing the J-35 alongside weapons like the LD-8A, designing internal bays to accommodate them, and exhibiting the missile with the aircraft publicly. Observers note that the display at Changchun Air Show, showing the J-35A with the LD-8A and other missiles, reflects an intent to operationalize the radar suppression role rather than treat it as an afterthought. Moreover, China's dual-track stealth fighter development, J-20 and J-35 in parallel, indicates an industrial strategy that supports rapid iteration and deployment. Coupled with the fact that the LD-8A is derived from an existing missile platform, China appears to have leveraged evolutionary design rather than starting entirely. From this perspective, the lesson is that generating a capability like this is not simply about one killer missile or one stealth jet. It's about the system: aircraft, weapons, sensors, mission planning, and doctrine. In achieving this, China has moved ahead of others, not because they lack the technology, but because the full stack was not yet aligned. That gap has now been leveraged. The impact of stealth fighters carrying anti-radar missiles is profound from a strategic vantage point. Radar networks underpin modern detection, tracking, and air defense systems. They enable early warning, target engagement, and defense of high-value assets. A platform capable of approaching these sensors covertly and neutralizing them shifts the foundation of aerial operations. In a region like the Indo-Pacific, where China's air and naval forces face well-equipped adversaries, the ability to disable radar arrays early gives a crescendo in advantage. For example, ground-based radar networks deployed by other states for area denial become far more vulnerable when facing an opponent whose stealth fighters carry missiles designed to home in on the emissions themselves. The result is a recalibration of engagements. Instead of the traditional struggle of fighters versus fighters, we move into an era where platforms disable networks before much of the air battle begins. Beyond the immediate region, this capability raises questions about how other nations must adapt. Radar systems may need to become more mobile, dispersed, or have redundancy built in. Sensors might need to run in passive modes, or rely less on strong emissions which make them targets. This means investment in counter-stealth detection, sensor fusion, and resilience becomes central. Additionally, the fact that this pairing appears operational or close to operational signals that China is not just demonstrating technology, but delivering capability. That has ripple effects. Export potential expands, deterrence calculations shift, and other air forces must plan for the scenario where stealth plus radar suppression is a baked-in asset. For our general audience accustomed to thinking of stealth jets as invisible attackers, the shift is clear. Invisibility alone is no longer enough. Offensive suppression of detection systems is now in play. The learning point? Future air power is not just about first shot or invisibility. It's about control of the sensor networks that enable or disable that invisibility. And with this capability, China has shown one path toward that future. China's stealth fighters now do more than hide. They hunt. By integrating the LD-8A missile into platforms like the J-35 and J-20, Beijing has taken a decisive step toward a new model of air superiority, one where invisibility is paired with precision and electronic dominance. This isn't merely a technological milestone, it's a shift in philosophy. It signals a future where air battles are fought not just between planes, but between networks of sensors and countersensors. The lesson here is clear. The first to see isn't always the first to shoot. The first to blind the other side wins. This isn't merely a technological milestone, it's a shift in philosophy. It signals a future where air battles are fought not just between planes, but between networks of sensors and countersensors. The lesson here is clear. The first to see isn't always the first to shoot. The first to blind the other side wins. To dive deeper, click the link to watch our full video and don't forget to like, share, and subscribe. Thank you for watching. See you there.